Our next section for review is about probability. Probability is really at the foundation of all of the inferential statistics that we saw in the second half of our course. So let's do a contingency table. Let's say we surveyed a bunch of men and women, and we asked them if they prefer salty sweets, or salty snacks, or sweet snacks. And of the men, 14 preferred salty sweets, salty snacks, 8 preferred sweet snacks, which gives a total of 22 men. For the women, there were 7 who preferred salty snacks, 12 that preferred sweet snacks, for a total of 19 women, which means we have a total of 21 salty fans, 20 sweet fans, and 41 total people. So those are totals in the last row and column. We should be able to figure out then what is the probability that a randomly chosen person is a man and prefers a salty snack. When we see the word and means both, so we want the man and the salty both overlapping. So in this case, there are 14 of them that prefer both of them out of the total 41 people. And then you could divide that and get a decimal if you wanted to give your answer as a decimal. But if I changed it slightly and asked what's the probability a random person was a man or preferred salty sweets, or now says that we're going to take all of the salty fans and all of the men and put them together in one bucket. The challenge is 14 people have been counted in both groups. So we're going to have to subtract out the 14 because it got double counted. So we've got 21 salty fans plus 22 men, and we subtract off 14 who got double counted and put that over 41. Put that in the calculator to find out. We've got 29 out of 41 is the probability a random person is either a man or prefers a salty snack. What if it was a conditional probability, though? What if we want to know the probability we get a man given they prefer salty snacks? Now, when we say given, that means we're only going to look at that section. So given salty, only these salty people exist, which means now my denominator is just the 21 salty fans. And we want to know of those 21, how many are men? 14 of them are men. We can actually switch it and say, what's the probability someone's a salty fan given they're a man? And while this is similar, now the given information is the men. And so for the men, there's now 22 total people, and 14 of them prefer a salty snack. So kind of similar in that the numerator is the same, but the population that we're interested in is different. It's either the salties or the men, depending on what's given to us. So that's our contingency table that you should be able to find probabilities on. Second thing you should be able to do is recognize the type of distribution and use that distribution to find a probability. For example, if 45% of a community support a levy, what is the probability that 5 out of a group of 10 people support it? Well, we're going to do this problem on Excel, where we're going to do equals. This is a binomial distribution. So we'll say binom.distribution. Because there's two options, either support or not support. And we want to know how many support it. So we want to know what's the probability that 5 out of 10, given a probability of 0.45, would support the levy. The last argument is going to be false because we want exactly 5 out of 10. If we made the last argument a true, it would add up 5, 4, 3, 2, 1, and 0 probabilities. So we can say equals binom.distribution, that we want 5 out of 10 successes with a probability of 0.45. And we're going to say false because we want exactly 5, not 5 or less. And when we do that, we get a probability of 0.234. So there's about a 23% chance that exactly 5 out of 10 people are going to support the levy. Another type of distribution we worked with is called the uniform distribution. Let's say buses pass by a stop uniformly between 5 to 12 minutes. We want to know what is the probability that I wait less than 7 minutes. Well, when we see this word uniformly, that tells me that the graph shape is a rectangle going from 5 to 12 minutes. The distance from 5 to 12 is 7. So the height is going to be 1 over that distance, or 1/7. We want to wait less than 7 minutes. So 7's right about here, and it says less than 7. So we want the area to between 5 and 7, because area is the probability. Well, area is base times height. This base is a distance of 2. The height is a distance of 1 over 7, because it's that all the way across. And so our probability is 2/7, or about 0.28. Uniform distributions draw a rectangle. But the other type of area distribution that we played with was the normal distribution. And the normal distribution is probably the most important distribution in all of statistics. Let's say that the average textbook costs $142 with a standard deviation of $34. We're going to first find the probability that a book cost less than $150. We can do these problems, these normal distribution problems, on Excel by typing in equals norm.dist, the number we're interested in, which is 150, comma the mean, which is 142, comma the standard deviation, which is 34. And then with normal distribution, we always have to end it with the word true. So we can say equals norm.dist 150, 142, 34, and then we always end with true on the normal distribution. And when we do, we get a probability of 0.59301. One thing to remember with the normal distribution is the normal distribution always gives the left tail. Because I wanted the book to be less than, we're on the left side, that was OK. But if it was greater than, we'd have to subtract our answer from 1 because we want the right tail. So make sure you're aware what tail you're in and what tail you want to be in. What if we wanted to know at what price are 15% of books under? 15% means the probability is 0.15. We already have the probability. We need to find what is the price. And so when we have the probability or the area, we're going to do equals norm dot inverse the probability that we care about, 0.15. And again, that has to be 15% in the left tail. If I was interested in the right tail, we'd have to do 1 minus there. The mean, which is 142, and the standard deviation, which is 34. So I can, on Excel, say equals norm dot inverse 0.15 with a mean of 142 and a standard deviation of 34. And it's going to tell me that that price is 106.76. What if we slightly changed the question, though? Let's say in a sample of 10 books, what is the probability the average cost is more than $150? And the difference here now is we've got 10 books. When we no longer have one thing, we're not asking about one book, we're asking about the sample of 10 books. Now we have to adjust the standard deviation to become the standard error. And the way we have to adjust that standard deviation is we take the $34 and divide by the square root of the sample size. Another thing that I notice is we want to be more than $150. So if I think about my picture, here's 142, there's 150. We want to be more than. We are in the right tail now. So to switch the tail in Excel, I need to say 1 minus norm.distribution. That flops the tail, so it gives me the right tail now. And I put in the number I care about, 150, comma, the mean, which is still 142, comma, the standard deviation, which is now 34 divided by the square root of 10, comma, we always have to type in true. So in Excel, I say equals 1 minus norm.distribution. That gets me into the right tail. Then the number I care about is 150. The mean was 142. And the standard deviation we said was 34 divided by the square root of the 10. And then we always end with true. The probability a sample of 10 books is more than 150 is 22.8%, or 0.228. This wraps up our review of the probability section. From here, we're going to move on in our next video to take a look at confidence intervals.